All right, welcome everybody. This is Fred Schankelberg, and welcome to today's Accendo Reliability webinar. And the topic for today is a shout out to Carla for suggesting this topic and asking a few questions a month or two ago about this. And I thought about it a little bit and realized there's lots of ways that reliability supports or is a part of creating a green product. And I'll get into a little bit more about what I mean by that. So thanks, Carla, and thanks to others that have sent over ideas over the years, as I enjoyed talking about reliability, and I especially enjoy talking about topics that you are interested in. So please continue to do so. So let's see. I was just sitting here looking at my we have a vaulted ceiling, and I got to figure out how to get some cobwebs out of there. So that's my project for later today. But beyond that, let's talk about green engineering. Now, one of the things I've have run into with green engineering and looking up a definition for it was that it's basically the practice of creating products that minimize the impact to the environment and are safe and cost effective. And part of that is just use less material. You know, if you can, like yesterday, I got a backup battery supply from Amazon, and it came in a really sturdy box that Amazon felt compelled to put inside another box and ship that to me. And part of it is not wanting to show the label while it's sitting on my doorstep or things like that, but it's just a generic box around a box, and it had no cushioning in it whatsoever. It really didn't need to do that. The box the product comes in is pretty stable. And I ran into that the other day. I don't remember what I ordered, but part of the option was, is it okay if we ship it in its original box, not wrap it in another one? I said, yeah, certainly. I don't need the extra cardboard. But that's part of the idea of reduce, is just use less things. And this is, as I was thinking about it, how does reliability play into this? And we'll talk about a couple of ideas there. And then reuse. Here in California, and I think it's a national wide thing, and I think Europe is kind of spearheading this, is the reuse. So if you take apart a computer or a TV or whatever, are there elements in there, like the power supply, that is perfectly fine and would work in another application, or would work in a different model, or could be directly reused? Things that still have plenty of useful life in them really don't need to head to the landfill. And so are you able to reuse something? And what I don't mean, using a hammer to drive in a screw kind of thing is not inappropriate reuse, but can I give this another life? And part of recycling, or not recycling, but reusing, say an old towel that's getting worn out in the bathroom, I certainly can use it in the shop as a shop rag, and it gives it another life for some period of time. And so I thought about, how do we involve reliability with this? And so there'll be a couple of ideas there. So just whetting your appetite here a little bit, and then recycle it. I got ahead of myself a little bit. There is a lot of work in different organizations, especially electronics, that you need to be able to disassemble your product, especially for the important metals, the hard to find, or the more copper or aluminum or tin that I can extract cleanly from a product, and put it back into use, the less mining we have to do. The hard part is that oftentimes it takes as much or more energy to separate these materials than it does to just go extract it from the earth. There is a finite amount of many of these minerals. And so recycling, again, is a force that's affecting many of our products. And more products are using recycled materials. I think there was even a road surface made out of plastic bottles that I saw advertised a few weeks ago. And again, it's, where does this fit into reliability? How does reliability make recycling viable? And what do we concern ourselves with there? And we'll talk about a few of those also. So when I approach this, and green reliability or green engineering isn't just reuse, recycle, reduce, reuse, recycle. But that's how I approached it for today's discussion. And then I want to talk about a handful of different ways that reliability and creating a reliable product or reliable system actually is a part and parcel to green engineering. All right. So I looked up this definition. And the basic idea is that it's good for the environment. It minimizes risks and it's good. And part of this is the pollution and sustainability and all those kinds of things. And it involves all kinds of sciences and engineering techniques to pull this off. And so a mechanical engineer that creates a product that uses less energy to create, in effect, is reducing pollution. And so it's that kind of thinking, is what's the overall life cycle from raw material to end of life? What's the total impact of a product or a process that you're putting together? And then how does that, what is its net effect overall? I saw one article when I was looking into topics for this. It was about aluminum. And aluminum is a very high energy metal to create. I don't think it's called smelting, but when they mine ore to make aluminum, or when they recycle aluminum, it takes an amazing amount of energy, of heat and pressures and so on, in order to create products from it. And even more so for things like titanium. They're very light, so they have a benefit of not costing as much to transport. They're very strong. They make, aircraft made out of aluminum don't need as much fuel to fly and so on. So there's always trade-offs. There's always balancing that goes on with this. But the idea of green engineering is that it takes into account all of those factors, not just that you got some parts made out of aluminum and they save you weight, you get a benefit on shipping reduction costs or shipping impact. But you got to account for, where did that raw material come from? And then what are you going to do with this raw material once it's no longer functional for what its intended purpose was? And so green engineering is much like reliability in that we often want to think about the entire life cycle. And green just implies that it's, what is the idea of what's its impact to the environment? What's the pollution and or destruction that occurs when we use those particular materials or products? As opposed to reliable, as we want it to be, that's something that just works over time. And they're related, but not exactly the same. So we're going to explore some of the ways I think they're connected in some obvious ways. And one of them is that, if we make a product that is just plain reliable, it has a number of benefits. And one of them, especially if we design a product that's just simple, right? And I remember years and years ago, I was working with electronics manufacturing facilities in Asia, and Singapore in particular. And we had a problem with this connector that in the wave solder, the connector would float up and it wouldn't seat correctly on the board. And then it required some rework. And so that took extra energy and extra time. And usually when reworking something, it didn't create as good of a joint. And so when that problem became apparent, one of the mechanical engineers, one of the American mechanical engineers, created a structure that fit over the circuit board. And it had springs and cams and all kinds of weird little things to hold about 6 or 7 of these components down on the board when it went through the wave solder. And it cost about $1,000 to make. And we were making on the orders of tens of thousands of these boards per day. And it was labor intensive. That only worked for about 3 days before it would, from the heat of the wave soldering process, would deteriorate and would no longer be functional. The springs wouldn't have any force in them, for example. And when we first saw it, one of the colleagues in Singapore I was working with, she looked at it and she said, I think I've got an idea. And the next morning she came in with these little bean bags that were sewn using high temperature resistant materials. And she just put the bean bag, those little bean bag, a couple ounces of weight on top of the connector, and it held it in perfectly. You could pick up the bean bags and reuse them. And as far as I know, they're still reusing them because they just didn't show any signs of wear whatsoever. And they didn't harm anything else. They were very easy to apply and to remove. It was simple. And instead of this $1,000 jig with metal and cams and springs and all kinds of doodads and screws on it and stuff, that after a few days was trash, this little itty bitty design insight made it simple and very robust and much less impact in a respect to a reliable product. So that was an example of a reliable process where it was simple. Now, the same applies for what you're designing and building. We often focus in on, well, what are the functions? And then marketing shows up usually, 2 weeks before launch and says, hey, how about this extra function? And it complicates the design. But if we could make a design that was elegant or simple, it generally means it has fewer parts. And in our process of design, we often have a deadline or cost constraints or all these other constraints such that simple doesn't occur. It's hard to do because it's difficult to do, to get the appropriate solution as simple as possible, but not simpler. And this becomes reliable because we're using fewer parts. We have fewer opportunities for failure. The function is optimized and it's hopefully robust also. Now, where reliability comes in is that a simple design tends to be more reliable. It just has fewer parts. It has fewer opportunities for failure, fewer moving parts, fewer solder joint connections, fewer types of material, and so on. It's not easy to do. It's something that we often work towards, but it's not simple to make a simple design. But it certainly is a green engineering technique, is to use fewer materials, fewer raw materials, fewer parts, fewer elements are transported around the world. It weighs less. It does all these other benefits that makes the product both easier and more resilient in use, but also simpler to assemble, and so on and so on. There's lots and lots of benefits to making it simple. And it really takes a focus in order for that to happen. And I've only seen it rarely where people focus on making the design as elegant and as simple as possible. So that's one connection that I've seen. Another one, and I mentioned it just briefly, is that if I can make something that is actually easy to assemble and uses components that are resilient to the normal amount of variability that's occurring in our supply chain, well, we can make that product more consistently. We can make that product on target or on spec way more often. And so not only do we get a better yield, we have less scrap in our assembly process and in our suppliers' processes. If we're holding somebody to very tight tolerances and they have a 50% scrap rate, well, that's obviously not a green design. If I create a design that allows me to use parts in their normal range of variability that we usually get, well, then I don't have as much scrap, not just in my operation, but in my supplier's operation as well. And so while it's not a one-to-one correspondence, products that have a good yield, that are easy to manufacture, especially on target for their specifications, and minimize the amount of variability, not only do we get the immediate benefit of less scrap and higher yields, but we also get a more reliable product. And that reliable product just lasts longer. And it has all kinds of benefits. For example, not going into landfill, those kinds of things. And so one of the things, and I've talked about it in many webinars, and I know people have worked on it in the past, is that looking at process capability in the design process and to set tolerancing, to select components and materials is a part of creating a reliable product. Because if I can't manufacture it, the likelihood of getting products into our system that are marginal at best to the needs we have for that product, its specifications, the more likely it is to fail. And so starting with the design is making sure that we are selecting components from capable processes, ones that are able to meet the design specifications. And I think it's a two-way street. Well, how specific can you make this piece of metal? What's the tolerancing of this process that we're using for this type of material? Okay, that's its inherent capability. What do we need for the design? Now, if I make it a tight tolerance, I end up with scrap. They have to filter it and sort it. If I make it a design that accommodates that amount of variability, we both improve our yields. And we probably will make a better product, a more resilient and robust product. And so one way we get connected to creating, reducing the impact, reducing scrap essentially, is making sure that from the design process and through our manufacturing process that we have very capable, and I'm talking statistical quality control capability analysis capable processes. And that reaps benefits throughout both green engineering and its impact to the environment, but also improving the reliability performance. So there's another area where we tie these together. And one of them I keep hinting at is, well, if we make something that just works and it just keeps on working, I don't have to throw it away. And I can keep using it because it serves a function. I've got a wooden spoon down and a couple of wooden spatulas. I don't know what wood they're made out of, but very durable and a little bit resilient or flexible, so they can stir a heavy stew or rice just as easily as a sauce. And I've had them for years. And I wish I knew where I got them or what kind of wood it is, but I don't. It's been so long, they're just durable. It just works. And I don't need to get new ones. They're doing just fine. So they're not in the landfill. And if I keep using those, then I don't need to cut another tree, for example, get more resources to make another one. The same applies for our products. Unfortunately, I'm looking at my iPhone sitting here on my desk and going, And I know somebody that has, I think, an iPhone 5 or 6, something like that. And after each generation of iPhone comes out, they provide backward compatibility for apps and all kinds of stuff for some time. But if you've got a 5 or 6 year old device, the likelihood of the capabilities of all of the applications will no longer be backward compatible. So you can't upgrade, you can't do all kinds of stuff with it. Excuse me, I think I got a cough here. Yep, I do. And so part of that is the advance of technology and capabilities and feature sets and so on. But part of it is a strategy to encourage people to buy new phones every year because it has new gee whiz things on it. And many industries do this, is they continue to evolve quickly when it's a new technology, a new device or new whatever. But iPhones, like cars, like many other technologies and other solutions and fields, will get a rapid increase in feature sets and capability for some period of time. And then the difference between the iPhone that's being announced today versus the one that was announced 2 years ago, I doubt there's going to be a huge difference. And so my phone that's now 2 years old should just work. And the electronics in it, as long as I don't drop it, I guess, it should just work. And it should work for a number of years. It's like cars. My dad got a new car every couple of years, mostly because he didn't want to do maintenance, have it down in maintenance in the shop or being stranded on the road, things like that. I think there's other reasons for it. But now I know many people, and myself included, will drive a car 10 years. I mean, if I want to, the last time I bought a car, it was to upgrade my stereo system, not for any other feature set that that car would have. And if it works and it's working well and you can trust that it's going to continue to be just reliable for you, we'll keep using it. If we can design products that provide a functionality and solve a problem for your customers for a long period of time, that's just straight up green engineering, because we're providing a solution, adding value with one set of resources that doesn't have to be replaced every year, like a phone, for example, or a car after some period of time. And so this is the obvious one for me, is if we make stuff that just works, we don't have to repair it. We don't have to throw it away. We don't have to stock spare parts. We don't have to transport anything else. We don't have to mine for additional materials or create extra materials, on and on and on. If we make a reliable product, a reliable solution, that's not a one-time use, for example, it just is way, I'm going to use air quotes here, green. So that's the obvious one. All right. So I think I answered this question already, is that when we're thinking from a reliability point of view, I've already mentioned, like, if we make a solution that works for an extended period of time, we actually have to understand what customers want and what's the market. So part of the scope, what we're dealing with, is marketing. Part of it is understanding what problem we're actually trying to solve. And part of it is, what's the strategy? Are we trying to make a kitchen appliance that just stands the test of time and is your go-to implements to use over and over again because it just works and it keeps on working? In the green engineering, its definition is to look at from its raw materials through retirement and its entire life cycle. Well, we often look at that same kind of scope with reliability. And a little bit different vein, we're not looking for environmental impact so much, but we are looking at very similar things like process capability and resilience to variations and stresses that it will see and still function and work for us. So there's quite a bit of overlap in the basics of what we do in order to create a reliable product that by default if it's reliable, it's green to some extent. It may not be totally carbon neutral, for example, but if we don't have to throw it away after 2 uses, that's generally a good thing. And so that's one of the fundamentals, I think, where they're related. Now, the other piece of this is, what's the cost of owning a product, of designing and building and owning a product? Well, one of the things I've run into, and many organizations do this, is they'll have an approved vendor list, or they'll have a catalog of components that basically say, it costs us money to bring on a new supplier. It costs us money to stock a new part. It costs money and space and time to have yet another screw, type of screw in our system. Years ago, I was walking through the mechanical engineering section for an HP facility for inkjet printers. And somebody had one of those poster boards set up outside their office, and on it were attached, it was like 87 different screws, and a drawing, like an engineering drawing of the printer, a 3D representation of the printer, with the arrow pointing at where each of these screws was used. And some of the screws, standing from, the untrained eye looking at them, I really couldn't tell the difference. They're small screws. One was a hex, another one was a flat blade, or a stand. I'm trying to think of what's the name of it, drawn a complete blank, but different ways of driving the screw. But the thread and the depth and the size they had were all very, very similar. Now, there may have been minute differences and some reason for them, but they were designed by different parts of the engineering team, and they chose different components. And it's just a screw. It costs a fraction of a cent. It's not a big deal. But when you add up 87 different parts in the system that have to be ordered and stored and cataloged and inventoried and everything else, it was something like $1,000 per component of overhead just to have that part in the system. And that adds up. And so part of an elegant design is using standard parts. Well, one is, it's like building with Legos. If you don't need to go create a new mold to create the fancy new dragon wings component for your design, and everything else is standard, you're only using one new part that has unknowns, that has variability that you need to sort out, it has all these other issues, plus it just has carrying costs to set it up and run it. But if you're using standard parts, you already know what works and doesn't work to some extent, to within the realm of where it's been used. So it's a cautious recommendation, is use standard parts, because you know a lot more about them and how they work and don't work. But it's with the caution that you need to know where the margins are, where's the boundary. Now, I'm not going to use a small thread screw to hold down something that carries a lot of weight. I may need a more coarse thread. I may need more threads on it in order for it to attach these two parts under those loads appropriately. I'm not saying pick one screw and only use that. No, because they do have different purposes and different capabilities. But if you've got 16 screws that all have 1 foot-pound of pressure, strain on them, or minor amounts of carrying or loads that they're carrying, use the same screw. Just, it takes a bit of effort and work to make that work. Yet the benefit is that it becomes more efficient overall. We have fewer trucks on the road. We have fewer cardboard boxes carrying these things. We have fewer totes in the storerooms for the manufacturing. We don't have to carry as many different kinds of screwdrivers, for example, and on and on and on. Even more elegant is don't use screws at all. I think there was an inkjet printer created by IBM way back when that had one screw in it because it was required to have the entry into the inside of this device had to be only accessible using a tool. And so they had snap fit for everything, but they put in one screw so that they met the requirement, some safety requirement of some sort. But I think you know what I mean, is part of the cost of ownership is the process of bringing on a new part. And that can consume resources, all kinds of resources, and increase risks of failures. It's part of what we do. We have to be able to do it and do it well, but we don't have to do it just because it saves me time picking a component. How about I pick a component and alter my design so that it works with the standard part? It has the environmental impact is where the benefit really is. Now, this one, I'm seeing more legislation and talk of legislation and requirements and regulations that are saying you need to make your device repairable. And I think part of the discussion is iPhones. I mean, they're amazingly complex devices under the hood. And I remember the early Macs when they came out 20 years ago or so, there were Mac repair shops all over the place. I had one of them, though, that it was in a school and the monitor actually failed dramatically with a small pop and a wisp of smoke coming out of the top of it. And this was a CRT type screen, not an LED screen. And so I took it to a repair shop and they said, I know exactly what failed, but it's a proprietary part. I can't get that part. It was called a flyback transformer or flyback. I think it was a transformer. And its function was that as the system would paint the screen, essentially one line at a time, this was a device that basically did the carriage return. Think of it as a typewriter. This is the one that said, all right, let's go back to the other side and paint the next line. And it expired. It failed. And other types of transformers and other types of flybacks would not work because it was designed to use this custom component. And so he couldn't repair it. It just wasn't possible for him because he couldn't get that part. And the transformer itself was so customized that he really couldn't start with another one, or he couldn't repair that transformer in and of itself. So he couldn't repair this monitor. Ended up getting a new monitor because it was more expensive to get that component than it would be to get a new monitor. Now, iPhones, you need all kinds of skills and tools to open these things up and do all the steps that go into it. And it's possible repair shops other than an Apple shop could do these things, but there's not an incentive for Apple to train these extra shops, these other places. It's to their benefit. You come back to Apple or you buy another device. More and more of the legislation coming out is that I think with autos and phones and a bunch of electronics is that the systems are becoming so proprietary and so customized that the basic diagnostic equipment in, say, an auto shop, it's cost prohibitive for them to have every brand of automobiles electronic sensoring systems to talk to the equipment to see what the issues are. And so there's movement in that area to do a standard way to communicate back and forth with your car for diagnostic purposes, so that a local repair shop can buy one set of equipment and it would work on all vehicles. That kind of makes sense, doesn't it? It's counter to the business model where the automakers want you to go back to the dealership because they've got a vested interest in the dealerships doing well, and that you get to see the new cars and all that good stuff. There's a lot of pushback in this area that manufacturers need to make things that are repairable. Beyond that, though, if you're creating a product and if it is a part or complex enough or expensive enough that it may need repair, it just makes, if I have to repair the screen on my phone, which I did numbers of times for my daughter's phone, I just take it to the shop, they take out the glass, they put a new glass in, and we're back and running. And it costs a couple $100, I think, or something like that, which is markedly less expensive than buying a new phone. But the same logic applies for whatever product you're making. Is if the expensive bits are still working, if the vast majority of your system is still working, and you've got a inexpensive component or a connector or whatever that's failed, and it might, the component itself may be only a few cents in cost, it may cost a few more dollars to execute the repair, but it saves the rest of that, say, $1,000 device. I'm thinking of a cell phone here. But the idea is that if I could, I remember years ago, HP had a workstation that it was used for CAD and for a variety of other systems, and it was a business critical machine. And if it wasn't working, then you lost the services of that engineer or designer for that period it was down. So what they did is they made the motherboard, it was a single big board that was in this box, replaceable by the customer. So if your system failed for whatever reason, you could pull out the motherboard or the power supply. They would do some diagnostics remotely and say, all right, do you need a new motherboard? We'll FedEx it over to you. They get it the next day. They pull out the old board, put the new board in, send the old board back to the HP to be diagnosed and repaired. It allowed the customer to be back in business within a day and not need a spare workstation and not wait a week for it to get repaired at a local shop or anything else. They made it deliberately repairable in an easy way. Now, that took some effort because you had to minimize the amount of connectors and make it so that it could be repaired that way. There was a design intent. Now, many of us don't think about that. And it comes with trade-offs, obviously, because you have to make things that you have to think through what's likely to fail, what's the level of repair, is it the whole circuit board or is it just the power supply or is it just this connector, or cable or whatever. What is it that we want to be repairable without damaging everything else? And the green part here is that if I can replace a connector and get your $10,000 system back up and running, well, that's wonderful. I don't have to transport the big box. I don't have to do diagnostics. I don't have to do all kinds of other things, including throwing away perfectly good parts that are disabled because one component could not be repaired. So there's a bit of this repairable. It's by design. If it's contrary to just make it reliable. If it just works, then I don't have to worry about repairing it. But if we think through about what's likely to fail, that's the reliability part, we can design a system that makes it efficient to be repaired. And I think that's where the green part comes in for what we do. Now, the green scope is really, from the start of the raw materials to retirement and what it's done with it afterwards. And it's the same for life cycle engineering when we are considering it from a reliability point of view. Is we should be looking at our suppliers and as far back as where it's relevant to what affects our products and its performance. if we get bad raw materials 3 steps up the supply chain and it creates customer failures for our customers, well, that's a reliability problem. So I think our scope goes all the way back to raw materials in many, many cases. But also at retirement, there we don't tend to be involved as much. What happens to your product when it's retired? Is it dismantled? Is it just taken apart for materials? Is it does it go back into some other supply chain? What does it do? It's usually not part of reliability, except how good is that power supply that's been in the field for 5 years? Is that now a new reliability issue for this new product? Is it going to cause a problem? How much remaining life is still in this stuff? Also, when using recycled materials, more and more of us are having to deal with materials that include some level of recycled materials. Are they as good or better or not? Do they have the same wear characteristics? Do they same response to stresses and so on? Those become reliability issues for us. So even though we don't often think about retirement of our products and the effect of where does it go, if it doesn't go to landfill, it probably gets recycled or reused in some way. And then the set of reliability questions still manifest. But if we can design the product right from the get-go such that it's robust, even when it's taken apart after its useful life for whatever its initial application was, once it ends that, how much remaining life is it? And that's a question that often involves thinking about it early in the process while we're designing the initial product. Where could this also be used? How could we get it to be used there in a meaningful and economical way? Those kinds of questions would come up. Sorry, let me take a pause here, get a sip of water, but what else should we consider? I've got 3 more on my mind, but there by no means is there only 9 ways that reliability and green relate to each other. So I've been yammering along here for a while. So chat windows open. So what do you think? What else should be considered a connection between green and reliability? All right. I think my throat's coming back. I'm not seeing anything. Oh, here we go. Operator touch time. So operator, like the end user, the person that's using it, or operator like in the in manufacturing process? I think so. One of the things that comes to my mind right off is I have well, we have a reliability problem with our power here in the area where I live. And one of the drawbacks of power outages, we've had on the order of 10 power outages over the last 6 weeks or so. Some only a few minutes, but some of them are 12 to 18 hours. Some areas in the mountains are like 3 days of outages. But when a power goes out here, one of the things that occurs is that I have a little hub for some smart light bulbs in the house, Hue light bulbs. And when it gets shuts off and comes back on, for whatever reason, it takes an extra power cycle to get it to fully re-engage. And so reducing touch time for me would make this one a whole lot more reliable, because if I don't have to plug and unplug this power cable to this thing after it's been power cycled already, And I think part of it is it doesn't reconnect because it comes up faster than the Wi-Fi comes up, and it needs to talk to the Wi-Fi system and the outside world in order for it to function. So when it comes right back up and says, hey, where's the Wi-Fi? There's nothing there, it times out and it needs a reset. So in a design scenario, it was probably thought of as, well, what if this module loses power and it comes back up, then it just goes through the power up and reconnects. Well, the assumption is that you already had a robust Wi-Fi connection that would be there already. Well, not all Wi-Fi systems and routers and cable modems and so on restore their capability very quick. If you've ever talked to a cable company, you know that they say restart your system and they'll wait 10 minutes for you. But the idea is that I don't think that was thought through. And so now I got to figure out, do I add components to it to put it on a delay before it restarts? Preferably, we'd get a power system that doesn't shut down power every couple of days. That would be nice. Oh, yeah, that's a good idea. Use one operator instead of two. So, you know, if the assembly of a process is simpler, designed for manufacturing, then you don't need as many people or equipment or tools or fixtures or jigs and all those things. That's one way to think of it. The other one is if it's a product that requires two different people to operate it. Can you imagine a car that one person had the steering wheel and the other person controlled the speed and the brakes? That would be fun, depending on who you're driving with. But if that was the norm and somebody came up with a way to do it all at once, that would be a pretty big leap in efficiency. Well, it would just simplify things too, is what I'm thinking. I know there's more to that. I'm just kind of spinning with all kinds of ideas, trying to figure out a good example or two. But good idea. The hard part is that we're getting more and more AI, artificial intelligence in our systems. I was in a Google Doc typing yesterday, and it was basically finishing my sentences for me. And it was doing a pretty good job at guessing what I wanted to say. You know, I'd start a fraction of a couple bits of a word, and it would complete this word plus the word after it, and make recommendations for it. So I was tabbing along while this, I don't think it was artificial intelligence, but pretty darn smart editor was making recommendations. Now, I don't know whether that was better writing or not, but I was pretty amazed at how well it was guessing what word I was trying to create and what the sentence structure was. And it really shone when I was doing a list, and I was and bulleted list, and it caught the parallelism right off. It was a verb with ing and then a short phrase. And so as I started typing the next line, it immediately jumped ahead to, well, this ends in ing. This is probably the verb you're looking for. And that was impressive. So that just saved me time and electrons and all kinds of other stuff to do it, except that I started playing with it to see what it would recommend. And that kind of wasted all the benefit I'd gotten there for a few minutes. But it was pretty cool. If only it could write my blog posts for me, that'd be cool. Probably not as interesting though. All right, here's a couple more that I thought of, and I'll touch on each of these pretty quick. One of them I hinted at earlier. If I make a system that the power supply and the motherboard are not integrated, I can replace one or the other and get the system back up and running. But also, I may be able to use that power supply in the next generation. So I don't need to redesign it and reset up the supply chain and reset up the manufacturing line, or have two different components in spares and spare parts and so on. If I can provide an upgrade by just changing the motherboard, not anything else. I don't have to change the monitor, the keyboard, the power supply, everything else. I just change out the motherboard. So what if I could take my phone down to Apple and they could pop out the equivalent of the motherboard and insert a new motherboard as easy as they could do a SIM card, and I have new functionality? Wouldn't that be cool? And I wouldn't have all the expense of all the other materials and assembly of this entire other structure. But no, every year we get a slightly different size and shape and thickness and all these other features to it. Apparently more camera lenses for, I don't know why that's important. But anyway, I digress. If I could upgrade my phone's capability to be on the current fastest chips, for example, as simple as changing out the SIM card, that would be cool. But apparently that's not how it works. But if that's a possibility for your product, then I could use that power supply, for example, or that logic board in multiple products. And I reduce the impact of my supply chain and of my inventories and of its repairability and on and on and on. It saves me in design time. It saves me on a lot of things. It needs some forethought, though. It's planning a family of products versus just planning one product. And not a lot of people think long-term. Too many other constraints that are placed on them to make that work. But it's one idea. And what we get from reliability is that we get ample time with, say, just one power supply. And we could fully characterize it, and we will know, and it has to be reliable because we're going to use it in different applications and different stresses and different loads, in different kinds of conditions, indoor and outdoor, so on. So it has to be pretty robust, but we can focus on it because we're not trying to create 8 different power supplies. We're creating one. And so it has some trade-offs and benefits to it, but we also get connected to it when, and the other part is that we have more time to refine that design to eliminate all the issues or bugs or problems with it. So it becomes very reliable because we're not starting over with each product launch cycle. Another one is the maintenance part of it. And I use Prognostic Health is the title of it, but it means proactive and predictive maintenance. It has amazing benefits to getting as much life out of the system before it wears out, but it also allows us to minimize our impact on spares. If we know 2 months prior that this chain on this manufacturing line, this belt is stretching, and in 2 months, and give or take a week, it's going to be unsafe or likely to fail, well, then I can order the part just in time to repair it. Well, maybe not with today's supply chain and the issues we've got. But the idea is that if I can anticipate, and this doesn't work for all failures or all types of failures for components and materials, but if I can anticipate based on usage rates, based on performance, based on current draw, based on something we can measure and monitor that gives me a trajectory to when it's likely to fail, then I can order the spares or replacement parts or do the maintenance before it fails, but not on a fixed schedule where I potentially waste a significant amount of useful functionality out of it. And so Prognostic Health is more and more being built into complex systems, but proactive and predictive maintenance practices work if we pay attention for specific failure mechanisms, usually wear mechanisms. And it allows us to monitor equipment and run it and use it for its full lifetime, and then replace it before it causes unwanted damage or downtime. And so it minimizes the impact on the overall system, but it requires paying attention and monitoring the signals that allow us to make that decision. This needs replacing, even though it hasn't failed yet. So that's an area where we get involved with quite often. And it really extends the uptime of our systems in a meaningful way, because we're doing maintenance when it's appropriate, not just because, or it's an emergency. And one more area is the storage transportation area. This example I used earlier, where I got a backup battery system for my computer, and it's a heavy device, and it came in a pretty thick walled cardboard box from the manufacturer, and it was well protected inside that box. I'm quite sure they ship it in that box. They don't put it in another box, but Amazon felt that they had to put it in another box. That provided really no additional protection to it. So part of our design, if we make a real robust product, allows it to be moved or stored or transported or installed where it doesn't get damaged. The damage then requires us to do replacements or repairs and so on, and it consumes resources. So if we make a robust product right from the get-go, it puts less requirements on the packaging materials that allow us to store it and transport it in order to keep it safe. Now, of course, this doesn't work with every kind of product and every kind of industry. But the idea is that if your product needs to be robust for its intended use, say a handheld device, it should be able to survive driving in a truck and not need shock absorbent material all around it just to be in a box in a truck. I remember when Amazon shipped books years and years ago, they were shrink wrapped down to a cardboard plate, which was then inserted into a box to keep the book from shifting around and damaging its corners or bending pages or doing stuff like that. More and more recently, books I've received are just basically in a loose envelope, polymer bag, essentially, and the books are fine. I don't know if they've changed the way they move materials around, or if they realize that the damage done on transport is so minimal that it's not an issue. I don't know what it is. I also saw a box the other day. It wasn't from Amazon, but it was somebody else saying our cardboard is half the thickness it used to be. And is that a change in the handling of the systems, or is that a realization that they had too much margin there and they can make it lighter and it's easier to move, and they still are, and they're not getting the damage to it. What I'd really like is the cardboard that Amazon sends out, and the tape would degrade easily. The tapes they're using, I have to strip off if I'm going to recycle the cardboard into my compost bin. The cardboard's fine. It breaks down just fine, and the ink's is a water-based ink. It just disappears. But when I tried this a few years ago, sifting through the compost bin with all this nice fresh compost, this nice soil that got created, and there's all this taping material, tape stuff, polymer tapes that didn't break down at all. So there's a suggestion for you if you're doing tape, but I digress again. So anyway, there's a few ideas on, I think I ended up with 9, give or take a few, connections between reliability and green. And I mentioned a couple of regulatory pressures, like the right to repair. The right to repair, I think, is the cause that's being there. Using fewer raw materials, recycling materials, end of life constraints. I've heard about for years now, packing materials and pallets that are sent back to the shipper or the person sending it, so they're reused. It seems to be more and more going on. So what do you see? What's going on in your part of the world? let's see, I think this is one other question to ponder is to think about, you know, what do you see as the connection? Did I miss any? And then what's the value of doing this? And hopefully this is an obvious one for all kinds of reasons. And I think I have one more slide. There we go. All right. Well, I'll stay on the line. Got a couple of minutes left in the hour, but as usual, I'll just stay on the line as long as there's folks around and questions to be answered or comments to be made. And appreciate you. Yeah, green is a very marketable word right now. I actually saw fat-free on lettuce years ago. I thought that was ironic. But it's also, I think it just makes sense in so many different ways. It's only one world, and we only have so many resources, and exploiting it and eliminating capability for future generations just doesn't ever make sense to me. Where I live, there's very few first growth redwoods. The whole peninsula, pretty much, except for a few isolated areas, were logged out. New Zealand, there was the British came in and they found, I don't remember the name of the tree, but it was perfect for spars for their sailing ships. So they basically cut the entire forest of these things down. So there's very few of them anymore. There's people trying to bring them back. It doesn't make sense to exploit a resource without thinking long-term. And that, I think, is slowly changing over the decades. Not quite fast enough, according to many people and myself included, but as it is. So anyway, thanks for attending and listening in on today's webinar. Thanks to Carla for sending over the idea for the topic. Hopefully touched on a couple of things for you that made sense. And if you've got other ideas, let me know. I've got, I usually plan 1 or 2 events out, but I'm always looking for good ideas. And if they come from you, that makes it a good idea. So look forward to hearing from you. Let's see, Carla's talking about more attention on materials and processes, long-term benefit. Okay, I think I touched on a couple of those. Yeah, and it's reducing the profit a little bit, but I suspect that if I get a product that just works, you could charge a premium for it. And so I don't know how much I paid for those kitchen appliances, those spoons and spatulas, but I think they were more expensive than the plastic ones that were sitting next to it. But I like the feel of the wood, and I'm glad I did because they're still there. They're still working. All right. You know, and I think I did hit record. So let me check that and end the recording, and I'll stay on the line. Hopefully everybody has a good rest of the Tuesday.